Okay. So we have 2 quizzes to take today. The first thing I want to show you that's not on the paper, if this thing will load. Come on. Come on. Is this. Okay. So let's say that the question says, like, the product is x. You don't need to write this down, but just look, okay? If I were to say the product is x squared plus 2x plus 1, I don't know, I just made something up. And then one of the factors is x plus 1. What's the other factor? So if they're asking me if this is the product means answer, and if one of the factors is this, what is the other factor? What are they essentially asking me? Like, think about what factors mean. Factors mean like what times what equals that. So if they're saying if this is the answer and one of the factors is that, then what is the other factor? What is the easiest way to find the answer? If it's multiple choice, because your test is multiple choice. Sorry, go ahead.
FOIL.
FOIL. So like take this, FOIL it, see if you get that answer. If it doesn't work, take this, FOIL it, see if you get your answer. Take this, FOIL it, see if you get your answer. Do you see how that's basically, that's what they're asking you to do? If one of the things, so they're saying like x plus 1 times what equals this answer, x squared plus 2x plus 1. What is the other factor? I don't know. So why don't you FOIL it with these answer choices to see what that would equal? Okay, so I feel like, what? Or distribute, yeah. Or do Grayson's favorite method, which is this box method right there. You could do that too. Okay, so I kind of just wanted to show you that because I feel like the wording you might not have gotten, but the math-wise, it's like super simple. Okay, so let's start with this, okay? This is the one where when you're factoring trinomials of a equals 1, they're basically asking you to do big X. That's really what they're asking you to do. Just do big X, okay? But you're going to see some that look weird. Like this looks like the box method, right? And you're going to see a bunch of problems like that. Well, you'll probably see like 2, I'm assuming, on average. So maybe let's review the box method first before I do anything else, okay? So all of you draw a rectangle and then make like 4 boxes in there. Because I want to review with you how to do this box method so that will help you figure it out later. Okay, so let's say my question was like x plus 3, so that's what I write on top, times x minus, give me a number, 2, sure. Okay, so let's say this is my problem. Then remember how I get my answer? Basically, all I'm doing is I'm taking like the horizontal and the vertical column and multiplying it together. So like for that box, what would that answer be? X squared, right? Because here I have an x times an x, which is x squared. Okay, so for this one, what would the answer be? 3x, right? Because positive 3 times x would give me 3x. Okay, then for this one, what would my answer be? Negative 2x, right? Because x times negative 2 gives me negative 2x. And then this one gives me negative 6. So this problem is really saying x plus 3 times x minus 2 equals x squared plus 1x, right? Because I can combine these two. 3x minus 2x is just 1x, and then minus 6. Does that make sense what we did many days ago? Like this is just basically the box method where you read this and you say, okay, that equals that. That one you multiply it goes here. That one you multiply it goes here. That one you multiply it goes here. Okay, so you're going to see a couple questions that kind of line up to that, but it looks a little bit different too. Okay, so why don't we look at this now? So, Ryan, the paper's on the blue counter, okay? Which equation is represented by this model? So here's my problem now. Do you see how it looks a little different, but kind of the same thing too? They just drew it a little bit different. Like you have bigger boxes, you have long boxes, you have small boxes. So basically like the X's are bigger and then the numbers are smaller. But does anyone think they know, like, what is this problem asking? Like, what times what? And remember the question's here, x plus 3 times x minus 2. So what would this problem be asking me to solve? Reed, is your hand raised or no?
No.
Okay. So like the problem, remember, is always right here. This section and this section.
Would be x squared plus 2x and x squared plus 2x.
Okay, wait, hold on. I couldn't hear you. So what'd you say? It would be what?
X squared plus 2x and x squared plus 2x.
Not x squared plus 2x. Just think about what this says right here. Rowan, what do you think?
And x plus 2 times x plus x.
Close. Closer. Cooper?
X plus x.
No. Reed?
X squared plus x plus 7.
Okay. Kind of. You guys are kind of getting like bits and pieces of this. Okay. So this one is the first parentheses, right? All you see are two x's and you're multiplying them because do you see how like x times x is x squared, x times x is x squared? So wouldn't this be the same thing as saying 2x, because I have two x's, times, and then what does this problem show you? I have an x and a 1 and a 1. So like if I combine that, not 2x, because this is what 2x looks like. So x plus 2. Does that make sense? I have an x, and then I have positive 1 and positive 1. That makes 2. So this side is x plus 2, and this side is, I have an x and an x, so I have two of them, so it's 2x. So what would that answer be if I didn't want to actually like multiply it all out and distribute it? Wouldn't that answer be, I have how many x squareds? 2x squared, and how many x's do I have? 4x. So, and they're positive, so that's plus 4x. Does that make sense how I got the question and then the answer? So someone was mentioning yesterday, like Ms. Friesenhan, when you were teaching me like the quiz review yesterday, they didn't ask for the question, but they asked for like the answer part. So I want to show you both just in case they ask for the other one. This would be the question. You have an x and an x, so that's two of them. So that's 2x times, this is always multiplied. You have an x and then a 1 and a 1 make 2, so x plus 2. So what does that equal? I have 2x squared, and then I have 4 x's, so it's plus 4x. Or if I really wanted to, I guess I could double check like that. That's 2x squared plus 4x. It's just a different way to show it. Okay, so now let's try this one then. So remember, the question is always going to be like the top and then the side. So this picture shows me something times something. So why don't we do this one first? Does anyone think they know this one? And these are negative ones. So it's x and then negative 1, negative 1, negative 1, negative 1. So what do we think that first one would say? Read.
X minus 4.
You have an x, and then you have 4 negative 1. So isn't that just minus 4? Okay. And then let's do this one on the side. Does someone different think that they know what that one would say? Grayson?
X minus 1.
So you have an x, and then you just have a 1 minus 1. So it's x and then minus 1. So that's what this problem is showing you. And then they solved it. So let's see what we have. We have 1x squared. I have just one of them, so I'm going to leave it there. And then look at all your negative x's, right? So you have negative, 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 negative. So how many negatives is that? 5. So minus 5x. And then you have a 1, 1, 1, 1. They're positives, they're not negatives. So what do I write at the end? Plus 4. So that's what this problem is showing you. Or I could just have FOILed it or distributed it, and I still would have gotten this answer, x squared minus 5x plus 4. Does that make a little bit more sense, maybe? Hopefully. Okay, because we're going to make it a little bit harder now. So what if I have this then? This time, do you see how it's not even filled out? I have to fill it out myself. So they gave me some of the question and they give me some of the answers. And I guess I kind of have to work around it and see like what I can figure out then. Okay, so let me grab some sticky so I can show you like how I can focus. Okay, so like what I would do if I were you is I would say, okay, so I see an x squared here. So really, I can just work on this one because isn't this answer this times this? So then I can think, okay, if this is an x, what does this have to be for this to be x squared? Cameron? X, right? Because x times x is x squared. Hey, so you gave me money back in September, so I don't need.
No, I didn't.
Yeah, you did. I think.
I don't think I did.
Oh, okay.
But even if I did, that's.
Oh, well, okay. Thank you.
You need it. Thank
Really?
you. I'm
Okay.
so sorry to interrupt.
No. It's okay. Okay, so do you see how this is an x squared? X times x is x squared. Okay, well, hold on. So if I know that, then maybe I can figure out this one. So I have x and a 1. So what do you think that answer would be? Just an x, right? Because 1 times x, or you can say 1x. You don't have to say x, but you can also say 1x. Okay, so then let's see if, okay, hold on. This is 3. So if this is 3, and that's the answer, 1 times what here would give you the answer of 3? 3. You see how I'm kind of just like working with what I have and doing it that way? Okay, so then hold on. This is the last empty one. So that would be what? 3x. Okay, so my question is this thing times this thing. So somebody online, do you think you can write for us? What is this question showing me?
X squared?
Not x squared. So like think of this. This is one part of the parentheses. So this is an x.
Oh, x plus 3,
Okay, so then this one is the other one. What does that show?
x plus 1.
And then that's my question. And then my answer would be, well, let's see in here. What's the answer? X squared. I have a 3x and a 1x I can combine. They're both positive, so I could say plus 4x. And then this last one is just plus 3. And if I actually tried to FOIL this out, I would get that answer. Okay. So again, I feel like they would just ask for the question, but just in case they're not asking for the question and they ask for the answer, I'm writing both options. So that's the question, that's the answer. Okay, and it also is all multiple choice, so I think you can maybe, it gives you a little bit more help than just being completely open-ended. Okay, can you try to do this one by yourself? Fill in all the blanks, okay? I'll give you a little bit of time. So you're filling this part in, and then whatever that would equal. So try to fill in all the blanks, working with the numbers that they give you and what you have. Okay. Does anyone think they know this top one right here? Ryan?
Top one is x.
Okay, so this top one is x. Because it says x squared, so then Ryan, what does that one have to be?
X.
Yeah, because you see how x times x gives you x squared. Okay, somebody different. What would this one have to be, Jack? Right, because if this is x, what times x is negative 2? X is negative 2. Oh, so if this is negative 2, and this gives you 14 as an answer, does someone know what this one has to be then? Cameron? Right, because negative 7 times negative 2 gives you positive 14, which means then that this part of my answer, one more time, what would that one be, Owen? Okay, so that's me filling it out, and now I need to write the question. So what is this picture showing me? Somebody online, do you think you know how I can write the question? Kind of like what Kip did up here. So someone other than Kip?
X minus 2.
And then?
X minus 7.
Good. Okay, somebody different online, then can you tell us what is the answer if I combine all the like terms?
X squared minus 9x plus 14.
Okay, so you have an x squared, so you write x squared. Negative 2x, negative 7x gives you negative 9x, and then you have a 14. And you know you got it right because if you actually FOILed it or multiplied it out, it would be that. Okay, so that's something that you might see on this quiz that you just might be like, what? So that'll help. Okay, let's do the back side. So it's kind of the same thing, okay? But this time, just more practice, I guess. All right, so here's the whole picture. You see, if you can't see clearly, I know the printing isn't great. This is what it shows. Okay, does someone in person think they can tell us the question of this problem? What are they trying to solve? Vaughn? Okay, so do you see how there's an x and then a 1, 1, 1, so that makes 3, and it's positive, so that's x plus 3. So this one right here that Vaughn just said is x plus 3. And then this one, you have an x and then just a 1, 1. So positive 1 makes 2. So that's x plus 2. Okay, so somebody in person other than Vaughn, what is that whole answer? And you can kind of just get it by looking at this part. Sienna, what do you think? And you know that she got it right because if you actually FOILed it out, then yeah, it would show that as your answer. Okay, let's do another one. This one we kind of have to fill in the blanks. Okay, so the partial factorization. So they like didn't do this part right here. They left it blank. So the partial factorization of this answer, x squared minus 1x minus 12, is modeled with algebra tiles. Which unit tiles are needed to complete the factorization? So, like, I need to know what's missing. So do you see how the plus means it's a positive and then the little lines means it's a negative? So this is like negative 1, 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 negative 1. Like think back to like second grade when I remember you had those like base 10 blocks. Like one little block was a 1, and if you put 10 ones together, you got a 10. So think of it as these are little ones, just like the number 1. Well, these are negative ones because they say negative. But then the long skinny ones are just x's because this is an x and this is an x. So this is like a negative 1, negative 1, negative 1, negative 1. Think of it like that. So x times x would have given you x squared. That's why this is a big fat one. X times negative 1 gives you negative 1x, negative 1x, negative 1x, negative 1x. So what do you think needs to be here? Three. Just 3 pluses, right? Because if it's just a 3 plus, this is a 1, this is a 1, this is a 1. So isn't x times 1 x? X times 1 x, x times 1 x, like that. And you know it can't be a long thing. It can't be another x because an x times x would give you an x squared. So if this were an x squared, it would be another big, huge block, right? So it'd be x, it would have to be like a single one. Okay. So then this would be what? X. How do I write the problem? Not 4x, because you have a long one, which is an x, and little, little, little. So do you see how that's x plus 3? Because you have 3 little ones. And then this one would be x, because you have only one long one. And then what would that be on the side? Minus 4. Okay, last one. This time, they give me nothing on the side. And I have to figure out what is all that stuff on the side. Okay, so when you see this, think to yourself, all right, so these long ones are x's. So this is like 1x, 1x, 1x. If this is a big one, that's not a 1x. What does that actually equal? X squared. So, and then like these little negatives here, that's just negative 1, negative 1, negative 1, negative 1, negative 1, negative 1. And then the long skinny ones, what would that be? Well, each one would be negative 1x, negative 1x. like that. Okay, so at least we can do this one up here. What is this one going to be up here and on the side to get me x squared as the answer? So x times x gives me x squared. Now I have positive 1, positive 1, positive 1x. So x times what, and what would give me plus 1, plus 1, plus 1. Just 1, right? Positive 1, positive 1, positive 1. Wait, but like right here, it's a negative. So x times what two things up here gives me a negative and a negative 1x. This, yeah, negative and a negative, right? And then over here, why are these so little? Because a positive times a negative is a negative. Positive times a negative is a negative. Positive times a negative is a negative, so on and so forth, 6 times. Okay, so let's write this question then. So on top, this would be not x squared, just the prob, x minus 2. And then on the side, it would be x plus 3. Okay. So you have about 22 minutes in class to get working on this. If you're still like super confused, then show me your problem during class time because you still have 22 minutes. And then